Hey, Nick. Do I need to do anything? Just plug in the HDMI? Sweet. Oh, we're live? Oh, so I shouldn't say bad things. Insider stock trading tips. Hey, everybody. My name is Eric Escobar. I'm a member of the Wireless Village. Every year, I get a lot of the same questions, so I figured I would distill it all into one talk. Just so if you have any questions, this is going to be a kind of just a walkthrough of if you have some random wireless device, you want to do something interesting with wireless, some good places to start when it's not just Wi-Fi. So let's get started and void your warranty. So I had a boss a long time ago that says, Eric, are you a creator or are you a destroyer? And this is when I was leaving a blue team to go to a red team. I am an engineer, so really when I think about it, I like to say I'm a creator, but I also like to break things in order to build even better things. So I'll walk you through a little bit what that means. So I'm sure a lot of you have seen all of this cheap hardware. It's all over Amazon, all over Alibaba, all over Temu, you name it. Basically, these are devices that just work off of some version of wireless protocol, wireless frequency that is replayable. So you can just go over and over and over again. Now, I don't really recommend you buy any of this if it's anything critical that you want to have set up. But it's really fun if you want to buy this type of hardware so that you can get extra functionality that you can program that isn't available on a lot of stuff out of the box. So things like thermometers, so like my wireless meat thermometer, that works on 433 megahertz. Motion sensors, door sensors, lots of those little like outlet things. And you might want to say, Eric, what does it matter if my wireless meat thermometer is in some way, shape, or form connected wirelessly? Well, if you can figure out how to demodulate it, decode it, and get the data off of it, well, then you can, I don't know, maybe write a Raspberry Pi script to monitor, your long cook, that's going to go over a couple of hours, right? So there's lots of things that you can do, and this is half about how to break something and the other half about why you might want to break something to, like, make it better. So if you see all these little caution stickers on the back of any wireless device, they will typically have an FCC ID. What that FCC ID is something that is going to transmit on the radio spectrum in some way, shape, or form that is released into the United States. Has to be tested by the FCC to make sure that it doesn't destroy the airspace, right? You don't want to have your wireless meat thermometer, make it so that you now can't open your garage door, right? So all these devices have to be power compliant. They have to fit within a certain band, a certain spectrum, in order for them to get approved. Now, that's what the FCC wants you to do, right? But what's even better about that is the FCC has done all the analysis on it, and as a part of that, these companies have to submit their design documentation to the FCC. So you can just take that number, you can plug it into a website called fcc.io, and now you can all of a sudden have the schematics to the wireless device that you want to hack. So it is like the ultimate cheat code of like, hey, how does this thing work? I don't know. They provided all the documentation online in a place that is easily accessible. So you can access things like test reports, setup photos, the user manual, schematics, all the stuff that like a hacker would really want to know if you're trying to learn how something works and how to break it, right? So going to this website, fcc.io, it is basically a direct link to the FCC website, and you can just plug in the unique identifier. And so if you go look at pretty much any wireless device, either off the shelf or off the internet, it will have that FCC ID, and you can go pick it apart and look through it. And the other thing that's interesting too is that you can see different iterations. So if it's like a product that's lasted out there a long time and they have to like resubmit, you can see the changes in between those different devices. So you can say, hey, what did they upgrade? What are they working on? Are there still gaps in security somewhere, or are there not? So talking a little bit about like the modulation and what all that stuff means. If you haven't done anything wireless, you probably haven't seen this before. But basically, there's two main types. There's amplitude modulation, frequency modulation. If you're thinking about like a pond, ripples in a pond, amplitude modulation is like you're modulating how high do the waves go in that pond. And then frequency modulating, you're modulating how close are the waves in that pond together. And those are a lot of things when you see frequency, like that's all that it is. Frequency is 1 hertz is just 1 cycle per second. So you can think of like one wave cycle going per second. That's 1 hertz. So it's easy to see in a pond. That's why when you hear all the nerds over here talk about gigahertz, megahertz, terahertz, you name it. That's what they're saying is terahertz is, gigahertz is in a billion, terahertz is a trillion. And so you get to know, that's how many frequencies, how many cycles are a second. And why that really matters is because if you look at the FCC website and you say, oh, it's frequency modulated or amplitude modulated, you know already, hey, this is what I need to look at. This is how the data is being transmitted. And then when you see the frequency of it, how many cycles per second something is, then you know if the hardware that you're trying to read that information back, if it's within the range, right? Because say you have a device that's 5 gigahertz or 2.4 gigahertz like Wi-Fi, but your wireless device that you're trying to read only goes up to 900 megahertz, you know that you're out of the range and there's no way that you'll ever be able to read that. So that's why you look at all that information and say, do I have the right equipment to even be able to read what's actually happening from the sensor from this device? And if it's some cheap, knockoff from Alibaba or Amazon, you'll probably be fine. Your hardware that you can get off of, Amazon for $20 will probably be able to read that type of encoding. But for more sophisticated things, it might be a little bit different story. So I just say that just to say, hey, be mindful of it. One thing that you'll see is in cheap electronics is something called on-off keying. You can think of it as that, if it's a 1, it's going to read a high signal. If it's a low, or if it's a 0, it's going to do a 0. And so if there's a certain clock associated with it, okay, it's basically literally just transmitting binary of 10, 101, 100, whatever. They call it on-off keying because you're literally, if you were like an old school PA system, if you were to hit the button to transmit, that's you're keying on, and then if you're taking your finger off the button, you're keying off. So that's the binary of how that's transmitted. And why that matters is there is a lot of devices out there that use that exact same modulation, and it's a lot of those cheap devices. And it's really great to say, okay, this is the basics of how this works, and that's where you always start when you're trying to break something like this. Is let's start small, maybe you'll get lucky, and then you just continue to ramp up your attacks or your analysis of whatever it is. Everybody here has seen a flipper? Yeah? Yes? Who has a flipper with them right now? One person? You should go ask the guy over there named Iceman about his firmware. That's the shirts that we're all wearing. Inside joke. He'll love you. So the next thing when I say okay, you have cheap hardware and you want to hack it is why do you want to hack it? What do you want to do to it? So in the case of a motion sensor, you might want to maybe make it so that motion sensor goes off even when there's no motion. Or maybe you want to prevent the motion sensor from going off. Or maybe if there's a door sensor, you want to make it say, hey, it's open. Or maybe you want to read that device and say, oh, okay, so for a great example of this is I have a cheap door open, door close sensor on my mailbox, right? And what is that good for? Well, it costs $3, on Amazon. And all it does is when the postman or somebody checks my mail, it'll typically send a chime off inside my house. Well, chimes are really annoying because what if I'm out of town? Useless, right? I won't be able to hear it. What if my kids are asleep? Now it's even more annoying because it's going to wake up my kids, right? So I like the idea of being able to know that my mailbox is open, but I hate that it's just designed to make a sign or a sound inside my house. So what you can do is say, hey, if I can read that signal every single time with maybe a laptop or Raspberry Pi or some other piece of infrastructure, well, now you have hacked that device. You've hacked that. You can read that signal. You can record that signal. And then you can have it basically do whatever you want after that. So we'll talk about how you can implement that going forward. I just like the idea of the flipper because now you have a handheld device that can literally do these replay attacks. You can also do it with those commands. That's how you do it in a HackRF. A HackRF is a software-defined radio that you can basically send and transmit frequencies off of it. But one of the things that if you look at something like a garage door remote versus a standard on-off, some devices will literally send the same code every single time, right? So if you're a bouncer at a bar and you have a password and it's hey, what's the password? You can keep getting into the club over and over and over and over, right? It's a replay attack where you can literally just say the same code over and over. A lot of cheap electronics implement it because it's easy, it's cheap, and it's been done for years and years and years. Other more sophisticated things like typical garage door remotes now, there's a little bit more security that you want to have behind there. Well, what happens is after you use that password or that passcode, it is burned and you have to use a new one. And so the devices know, hey, which is the one that you have to use over and over. And so that's how you kind of get into this zone of things get a little bit more complicated as they get a little bit more complex and as security is a little bit more necessary. So something like a, door open, door close sensor, maybe there's not as much security as opening your garage door. But devices like the flipper, the HackRF, any of those replay attacks can easily be done with that off-the-shelf hardware And I just say it because if you're trying to hack something, start off easy. You might get lucky. You might get surprised where those vulnerabilities fly out. The next thing is that if you're specifically looking at 433 megahertz, there's a tool out there called RTL 433. Basically what that does is it takes, it ingests a ton of data on that specific frequency, and it will analyze it automatically against known signatures, against known protocols, and against known things that are out there. Why does that matter? Because you don't have to do the legwork to do it. Could you go decode a bunch of signals? Could you try and figure out, oh, what is error checking? Could you try and like figure all this information out yourself? Yes, but why reinvent the wheel if you don't need to, right? So, the reason that I say RTL 433 is that there's a lot of, the radio spectrum is everything from like visible light to like, X-rays, gamma rays. Like you can think of anything is technically in that radio, the electromagnetic spectrum. But the United States government has said, hey, you can transmit without a license on 433 megahertz. So that's why a lot of the cheap electronics say, hey, we don't need a special license to transmit on this frequency, so we just use this one because it gets you a decent amount of range. It's not absorbed by a lot, and that's what a lot of cheap consumer electronics use. So that's why this tool focuses specifically on that narrow section. There are other tools that focus on other narrow ones, but typically the cheap stuff that you're going to buy off of Amazon, that's where it's going to be. And so if you were to fire up with a tiny little $20 dongle that you can get off the internet, you can basically decode all the different things that are in your neighborhood. You can get the power reading from your power meter if you're anywhere except for California, you can probably read the power coming off of your power meter just using a cheap dongle like this. You can do, like I said, your barbecue thermometer meter, right? Your door open, door close sensors, your tire pressure sensors. This is one of those things that it just has a ton of information in there, and so it's worth throwing whatever device you're trying to break into it and analyze it using this because it might have already done that legwork for you. Next, if you're trying to, if you can't get it using any of the aforementioned tools, right? Your flipper is not working. You have your what's it called? The HackRF. You can't see anything. Easily replayable from there, and you're like, gosh, I guess I need to actually do some legwork and look at something. There's a tool called Universal Radio Hacker. You can apt-get install it. Really, the nice thing about this tool is that it takes the radio spectrum that's out there. It takes your HackRF, your BladeRF, whatever wireless software-defined radio tool that you have, and it makes everything really easy to analyze. It kind of gives you like a good workbench, a good workspace to analyze what are you looking at. How do you convert radio waves from something that you have no perception of to, oh, okay, that's at least a 1 or a 0. When I press this button, this code gets transmitted, right? It makes it to something that your eyes and your brain can register in a way that's not like too ephemeral. And so using this tool lets you do a lot of different things. On its most basics, it lets you do signal analysis. You can even do replay attacks with this. You can do fuzzing against it. You can do simulated different wireless things. And you can basically just figure out how shit works, right? It lets you kind of go through, gives you that workbench where you can basically open up that wireless signal and just, inspect it with, digital scalpel and say, oh, this is what happens when I press that button. Is the code rolling? Is it, is there error checking in there? Is there any potential for me to do something nefarious in there? So just to crack it open a little bit and show you what's actually in here. This is an example of my garage door alarm. So I have a brake beam sensor on my garage door so that if any of my kids are to like run out into the street, or if anybody after midnight rolls up to my house, I can say, oh, somebody's now in my front yard, right? I now know that. But I want not it just to make a sound in my house. I want to understand, okay, how can I get potentially a text message on my phone when I'm out of town? How can I basically analyze the signal and figure out, are there other people that also have these sensors somewhere in my neighborhood? They transmit pretty far. What does that look like? And so you can get a raw signal like this. And if you look at the image on the far left, I think I have a closer up here. You can see, you can do things like, okay, you can see, is there noise? You can take noise into account. You can see how many samples a second. What type of modulation do you want to do? Do you want to do, how many bits per symbol? And it'll even do auto detect. That's the next part about this, is that the auto detect is sometimes the easy button. The software will basically go through a lot of known combinations of error checking. It'll go through a lot of known combinations of different protocols that are out there, different modulations that are out there, different spacing, different error correction, and it does that all automatically. Now, is it perfect? Absolutely not. But it's good to just go hit that auto. auto detect button say, oh, my job's done. I have the information that you need. But that's where the next part of this comes down to, and that is what do you want to do? When I'm talking to people at the booth that come up to the village, and they say like, well, how do I hack this? And it's like, well, why do you want to hack it, right? If it's a if it's some junk piece of hardware off the internet, why do you want to hack it? Well, what's the purpose for it? Do you want to use it for something? Do you want to play a practical joke on someone? Are you trying to find other known vulnerabilities that this place or that this hardware might be utilized? And then sometimes if you do want to use it for something constructive, knowing this information allows you then to say, hey, I can ingest it here and I can actually like make use of this. And I'll talk about how you make use of it after you've hacked it. So you can do like things in this analysis tab. So you can basically break apart this signal, and you can view the data in several different ways. So if you see like right here, I don't know if this shows up right here, you can analyze just the raw bits. So ones and zeros for whatever modulation it is. You can decode it if it's Manchester 1, Manchester 2. You can invert it. It's all these things that you could do in a tool like GNU Radio, but you don't need a PhD to try and figure out how to use GNU Radio. It lets you just see it and play with the signal. And then as you see here on the tabs going forward, I'm not gonna draw this out, but you can use it as a generator. You can simulate, so you can generate your own signals. You can simulate your own. How does it work? Does the error correction actually work if you're trying to generate your own? One interesting part of this is that like, have any of you guys have like seen those little dog remotes for their like dog shot collars, so to say? They all work off of this exact same 433 megahertz. We used to have a challenge out here that was like, hey, we're going to put 2 different channel dog collars on 2 different contestants and see who can shock the snot out of the other person. But what's a little terrifying that we figured out in that is that even though you can only go up to 100 power level in the shock collar, the key space actually allowed for 255. What could go wrong, right? Like, what could go wrong there, right? And so that all comes back down to, like, what is your goal? Do you want to shock the snot out of somebody else? Are you trying to defend it so that you don't get shocked? And the interesting thing about that challenge here is that there's a lot of pressure when you're trying to decode and analyze a signal when you know that there's a shock collar strapped to your leg. Like, you've never had that much pressure on you. Well, maybe some of you have, but I haven't. Like, I've never wanted to be shocked. So when you look at this, you can basically say, okay, well, if I know what one like, say, dog collar looks like, what happens if I press another button on that remote? What bits actually change in this? And so then you can start to analyze the signal and say, okay, well, this bit flips, that bit doesn't. Or maybe this hex, goes from an 8 to a 9, right? And so you can start to understand, okay, well, what happens? What additional functionality does this have? Or what's actually being decoded? What's actually happening in the signal that gets transmitted? And again, all this does is this just lets you visually see it. And so when I'm speaking with contestants, when I'm speaking with like what do you want to do? This is the best way to analyze it. Now the hard part is if you're trying to analyze a signal and it's a signal that is just replayable, so it's the same thing over and over. That's where you really need a couple different devices from the same manufacturer to say what changes from device to device from that same manufacturer, so you can see where is their preamble, where is their bits that flip or anything like that. Okay, so I've spoken a lot. I kind of want this to be interactive. Does anybody have any questions? Did I say a word? My goal is to not say a word that somebody doesn't know what that word means without explaining it. So is there any jargon that I use that somebody wants me to like, hey, idiot, you didn't explain what a software-defined radio was, right? And I just say it because I think everybody knows what it is. So does anybody have any questions? I'll stop here and just ask. Boom.
What was the name of that tool again?
Universal Radio Hacker. Anybody else? It only works with certain ones, but it's it's like AirSpy, HackRF, all of the like the digital like USB ones that you plug in from Amazon that are like the TV ones. It does. Oh, gosh, it's a lot of them. Like pretty much anyone that you would go buy, like off of like a typical website, it's probably going to be supported. I don't know. We can look after this if you want, but yeah, it's pretty like. I think almost all of my SDRs, except for some of my Edis stuff, is not available. Yep, that definitely works off of it. That I actually use that same dongle to read my power meter, which is also really cool. You could go buy can you hold up the dongle that you showed? So that little dongle, I can read what the power usage is off of my power meter. And so why is that important? Well, think about it. Like, I can see in real time how much power I'm using. So if I have solar panels, batteries, all that stuff, I know what the utility company is being transmitted. So I see it at its most raw form, what's actually being transmitted to the utility company, what's happening. And then, you know, if anybody's a developer, programmer, coder, like whatever it is, then you can make use of that data and say like, oh, here's some analytics. And it's going to be far higher resolution than what anybody could actually ever, you know, give you as far as like download, you know, a CSV file from your energy provider. Any other questions before I keep going? Oh. What was that? Because California is the worst when it comes to PG&E. I don't know if you heard about PG&E in the news, but they're the absolute worst. Their meters, a lot of them just don't have that protocol decoded. I think there's some private information in there that can't be disclosed, and so you can't just like read that data. You need some specific device that they've done some licensing agreement with. I believe that's why you can't read it. All I know is that all the like typical meter reader protocols don't work on a lot of devices that are run by PG&E in California specifically. So that is my experience. I live in California, and I cannot read my meter despite a lot of, like my newer meter I can't read. An older one I definitely can. Any other questions? I can keep going. Cool. So has anybody heard of NodeRED? So it's kind of like this like open source like IoT like thing. Really, what I like about it is like I'm not a developer. I'm a hacker, right? So I like to just like I want things to work, or I want them to break, and I don't want to invest like a ton of time in like building a framework to like make it happen. I just like want to like have it work, right? So what I really like about this tool is that tool that I showed you, RTL 433, they have a plugin for this, and so you can ingest wireless data, and then you can make use of it in this like neat, easy to use, click and drag programming language, right? And so you're thinking like, okay, well, like great. So like, why does that matter? What could you do? All right. Well, you can build like custom flow graphs like this, right? So if you get a cheap temperature sensor, if you get a cheap open door sensor, right, you can read all of these from the different sensors that are out around your house. So if you have like a power meter, if you have like I was saying, the brake beam. And then you can basically say, okay, I want to log this data somewhere. So if you have a bunch of temperature sensors and you're monitoring, say, I don't know, your greenhouse, your neighbor's greenhouse, your dog's smart collar, your neighbor's dog's smart collar, because you want to know when they go on a walk and when they don't. I don't know what creepy things that you do with your time. You're the ones that have asked me these questions, right? But essentially, you can use this tool as like a way to like make these just like random wireless signals that get transmitted and actually make them usable, make them into something that you can log, you can look and work and do analysis later. So so you're getting to this point where hey, you bought some random cheap electronic and it makes a tone in your house. It does something dumb that you don't want it to do and you want to expand its functionality. Could you go buy something off the internet that does it for like $200-300? It's like Wi-Fi connected. Probably so. But would you rather waste your time that's probably at a much higher billable rate to hack something? Absolutely, because it's cool. And then you can give a talk about it. But like, if you look at just kind of like all the different things that NodeRED can do, and there's not just NodeRED, right? Like you can, if you're at all well-versed in Python and ChatGPT, you can write programs that will analyze all this stuff for you too. I like this from the standpoint is that they have plugins so that I can receive a text message. I can receive a push notification to my phone. So I can basically take something and say, hey, I got my barbecue, it turns out my tri-tip or my filet mignon is at 135 degrees Fahrenheit, and maybe I'm not within range to hear my timer going off, but I get a push notification to my phone while I'm at my neighbor's house that says, hey, your steak is ready. Or maybe your steak's going to be ready in 5 minutes. Or maybe you just want to see the temperature characteristics of your Traeger barbecue, and so you want to analyze the temperature and how long it takes to heat up on a 100-degree day. I don't know. Again, you guys are the nerds that ask me these really great questions because then I have to implement it and have to do it myself. So I say all of this because there's way more functionality out there than something you can do off the shelf. And so just my whole goal in this is like, look, analyze the protocol, see what's out there, because you never know what you're going to be able to do with it. And then you never know if you're going to actually be able to use it in a security situation, right? Because the same thing that's going to let you know that somebody has like walked up to your house and the motion sensor goes off is also the same tool and tactics and techniques that's going to let you basically open a security gate to a secure facility, which we've used in a red team, right? So the same tools and tactics and techniques that you have, you can use them in a multitude of different ways. So I just say this to say, hey, there's constructive things you can do with it, there's negative things that you can do with it, or you can just try and make the world more secure. I think that's the end of my slides. Does anybody have any questions? Again, I could talk about this stuff for like hours, days. Like I could talk about NodeRED for like an entire hour presentation. I could talk about universal radio hacker for an entire presentation. But my whole goal in this is just to say, this is what's possible. Go try it. Yeah, let me go back to the slide. Yep. Yeah. So if you just go git clone this sucker, if you go git clone it, it's all right there. So they have the known database that's already built in there, and then you can add your own stuff. If you find new stuff, you can submit to it. Yeah, if you find something new, by all means. Yeah, so the Yardstick 1 is probably the best bet for that. Yardstick 1 is, I think it's like $90, but it allows you to transmit, and it does all like, I shouldn't say all, it does a lot of the good ISM frequencies that are sub gigahertz, so sub 1,000, was it, megahertz. Any other questions? Way in the back. You got to talk loud because I can't hear you. In California? Oh, not in California. There is, if you look up RTL 433 and then AMR, and I forget what, I think AMR stands for automatic meter reading, or something along those lines. You can go look it up, and I'm sure that basically what you'll do is you'll run RTL 433, and then that'll like create like a server aspect, and then you'll have another program, the AMR reader, that will read the data from RTL 433. Any other questions?
Any recommendations for a sub $1,000 SDR that's not a hack RF or a blade RF?
I like the Yardstick 1. Yardstick 1 is like $100, is what I just mentioned, and it lets you transmit it, and it's sub 1.
It's not really an SDR though, right? It uses chipcon stuff, so it's defined protocol.
Yeah, I guess you're right. Yes, it works for a lot of stuff. I'm trying to think of one that transmits. That's not a hack RF. I think there's a Lime SDR. I think Lime SDR is that's another pretty good one. Oh yeah, and there's a hat for Raspberry Pi, but I mean to get a Raspberry Pi now is like $1,000. So at that rate, you got to just go buy a Blade RF. Man has 6. Give him some Bitcoin. Oh yeah, that what? Can you say it louder so that he can hear it? Adam Pluto, that one's pretty good too. Adam Pluto, right? That's what it is. Yeah, 80. Yeah, I don't. When you come after, we'll find it. Yeah, just Pluto SDR. You'll find it that way. Any other questions? Going once? Going twice? Sold. All right, you can also find me at the Village too. All right, thanks everybody.